Okay everyone, we're going to continue on with square roots. What we're going to do today is we're going to estimate square roots. So remember last day we had something look just like this, and I asked you to make some squares. For example, I asked you to make a square that had 9 little squares in it. And you were able to do that. You go like 1, 2, 3, 1, 2, 3, and you end up with 9 squares in here. And because of that, each side was 3 and 3. So we talked about two things. One, because of this, we could take the square root of 9. It's a perfect square. And the perfect square of 9 is 3. And the reason for that, the reason that the square root of 9 is 3 is because 3 times 3 equals 9, right? So we had numbers like 9 and 16. If we did 4 by 4, we could do 16. 25, 5 by 5. 1, right? Perfect square. 4, perfect square. 9, these are all perfect squares. But what about, and I did talk about this last time, what about if we didn't have a perfect square? What about if we had a number like 17? Well, that's not a perfect square, so I can't make a square that includes, exactly 3 or exactly 4 along each side. I mean, the square root of 16 is 4, so I would go 1, 2, 3, 4, like that, but I'd have to go just a little bit further, wouldn't I? And then I go over this way, 1, 2, 3, 4. It has to be a square, so I have to go that little bit extra there as well. Just I did a little extra here, I got to do a little bit extra there as well. Then I go straight up from there and across. And, there very well could be around 17 in there. I probably haven't nailed it, but if we were to count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and we need one more. So, I would have had to try to make it so that all these ones that are just hanging off the outside here, those would all add up to one more. I mean, it's pretty hard to do. It's not precise and perfect like here. So a number like 17 is a non-perfect square. You can't make a perfect square with it. So when you take the square root of these numbers, you don't get a whole number. You don't get a fraction either. You end up with an irrational number. Well, that's good, but what's an irrational number? An irrational number is a number that has a decimal that never terminates. Terminate is just a fancy way of saying end, and it never repeats either. So, for example, people often have a hard time really understanding this. If I wrote a number like 4.23186 and then I stop, well, that terminates. So that means it's not irrational. Right? It would actually be called a rational number. Or if I wrote something like 4.32 and this is all repeating, okay, it doesn't stop, it keeps going, 32, 32, 32, 32, but it repeats. So both of these ones here, these are both rational numbers. Rational. An irrational number is a number that never stops and also doesn't repeat. So an example could be something like, 1.231847156123419112112 ... And what I mean by the ... is it just keeps going on and on and on. I don't mean it repeats. I mean it just keeps going on this kind of random series of numbers. And that's an irrational number. And it turns out when you take the square root of any number that's not a perfect square, you get a decimal like this. You get an irrational number that goes on and on and on and on. Here's the other thing about irrational numbers. They cannot be written as fractions. Any number that can be written as a fraction is a rational number. Any number that can't be written as a fraction is an irrational number. So, believe it or not, I'm not going to get into this right now, but these numbers here, 4.23186, this can be written as a fraction. 4.32 repeating, that can be written as a fraction. 1.23184 going on and on forever, that cannot be written as a fraction. Okay, so what do we do if we want to get the square root of a number like 17, right? Remember, if there's 9 squares in this perfect square, then it's easy to find the square root. I just count up this side, 1, 2, 3, and that's my square root. But on this one, where I have 17, it's harder to figure out the square root. It's this amount right there. Well, what amount is that? It's 1, 2, 3, 4 point, 4.1, 4.2, 4.123. In fact, it gets worse than that, because remember what we just learned. It's actually going to be a decimal that goes on and on and on forever. So how on earth can we estimate these things? Well, one way you can do it is with a calculator. But guess what? even a calculator is just an estimate. How come? Well, let's take a look at one. Let's do the square root. Well, why not? Let's do this. Let's do the same one we were just doing, 17. Let's say we did want to know the square root of 17. So I'm going to go and find a calculator online. Okay, here we go. I know this is a weird looking calculator, but I want to show you. You get square root, see this SQRT, that means square root of 17, and then I'm going to execute. I'm going to do this, and you're going to get the answer down here. You ready for it? There it is. 4.123105625617660549821. I mean, come on. That is an incredible answer. I think there's about 21 numbers after the decimal point there. That's incredible. So is that the exact answer? I mean, come on, 21 decimal places. Is that the exact answer? No, it's not. How come? Because this decimal just keeps going on and on and on and on forever. So even this is just an estimate. So actually, you wouldn't write equals like this because we're only getting an estimate. We're not getting the exact answer. What we do is we write this. This means is approximately equal to. You could also write it like this, equals, and then with one of those on top. Okay? Either one. I tend to do the double wavy thing like this. All right, so what did we say it was equal to? Approximately equal to 4.1231056. I think it was 256 after that. I can't remember. Anyway, it goes on and on and on. It goes on forever. It's just an estimate. Okay, that's one way to get an estimate of a square root. Sadly, you will not be doing that in this chapter. You're not allowed to use calculators in this chapter. I'm so sorry, everyone. Even the, what do we call them? The crapulators, the crummy calculators, you can't use those in this chapter. So you need a second method, and here's your second method. You're going to use the perfect squares as benchmarks. You know what a benchmark is? A benchmark is when you compare something to something else. So it's like a standard that you compare to. So you're going to compare these non-perfect squares to the perfect squares. So it's a two-step process. The first step is you're going to ask yourself, what two perfect squares does the radicand fall between? Radicand, what am I talking about here? Well, I haven't talked about this yet, but anytime you put down the square root sign, that square root is called a radical sign, and the number inside is called the radicand. That's a radicand. So the first thing I do is ask, which two perfect squares does the non-perfect square? Which two perfect squares does the non-perfect square fall between? And this is going to help you determine the number in front of the decimal in your answer. And then the second thing that you should ask yourself is, figure out whether that non-perfect square again. Figure out whether the non-perfect square is closer to the smaller perfect square or the bigger perfect square. This will help you determine the number after the decimal in your answer. We're only going to figure out one decimal place, okay? If I ask you to estimate these things without a calculator, you can't do it more than one decimal place. So just one decimal place. We would be estimating square root of 17 to be somewhere around 4.1. All right, let me go through this. Now that you've written that down, hopefully, I will show you what it actually means. So, if we wanted to know what the square root of 11 is approximately, what we do, here's my first 15 perfect squares. I ask myself, where does the square root of 11, where does it fall on this list here? Well, it falls right in there, doesn't it? Right between 9 and 16 comes 11. So, let's figure out what the square root of 9 is, and let's figure out what the square root of 16 is. Well, those are no problem because those are perfect squares. You're going to get nice whole answers. What is the square root of 9? We're looking for a number that multiplies by itself to get 9. It's 3. Or here's another way you could do it. 1, 2, 3. It's the third number over in the list, so the square root must be 3. What's the square root of 16? What number multiplies by itself to get 16? 4. Or if you want, 1, 2, 3. It's the fourth number over, so 4 times 4 equals 16. 4. So the square root of 11 must be between 3 and 4. If it's between 3 and 4, what kind of number must it be? It must be 3 point something. It could never be 4 point something if it's between 3 and 4, because if it was 4 point something, it would be bigger than this amount, right? Okay, that was the first step. Second step, you're going to ask yourself, is 11 closer to 9 or 16? Well, it's definitely closer to 9, right? It's down here. There's only 2 steps here. There's 5 to get from 11 to 16. Well, if it's closer to the smaller one, what do you know about your answer? It better be less than halfway. Halfway would be 3.5, but this number 11 is not right in the middle. It's closer to 9, so it should be less than 3.5. I don't know. What would you say? Maybe 3.1? I'd accept that answer. 3.2? I think I'd accept that one too. 3.3? Maybe. I think maybe I'd even accept that. I wouldn't accept 3.4 or 3.5. I think that's too much, right? It's not in the middle. So I think it's either 3.1, 3.2, 3.3. You write any one of those. You don't have to write them all. You write any one of those down on your page, and I'm giving you the marks. Now, you want to know exactly what it is? Let's go use that crazy calculator. So I'm just going to change it from 17. I'm going to change it to 11. Execute. And we get, to one decimal place, 3.31. Well, that just rounds to 3.3. So there you go. 3.3 is the answer. But you're not going to use a calculator, so I'm just showing you 3.3 was the real answer, just to give you a sense. Okay, square root of 47. Where does that fall between? Well, that's between 36 and 49. So why don't we figure out what the square root of 36 is and the square root of 49 is? Square root of 36. What number multiplies by itself to get 36? 6. Or if you want, 1, 2, 3, 4, 5, 6. Yep. What number multiplies by itself to get 49? It's always going to be one more than this one, isn't it? So it's going to be 7, I hope. 7 times 7 is 49. Yes. Or if you count up, 1, 2, 3, 4, 5, 6, 7. Yes. So what's our answer going to definitely start with? It's going to start with 6 point something. Again, I'm going to say this again. It couldn't be 7 point something, because if it was 7 point something, whatever number you put here, even if it's a 1, that's now going to be more than this amount, this 49. We want it to be less, so it has to be 6 point something. All right, that's the first step. Now we got to get our decimal number after here. So what do? We ask ourselves, does 47, is it closer to 36 or 49? Definitely closer to 49. So I'm going to put it right there, 47. All right, so if it's closer to 49, it's closer to the bigger one, what do you know? Half would be 6.5. This must be more than half. And a fair bit more, right? There's 13. Half would be around 42. We're at 47. That's quite a bit more. I wouldn't say 6.6. Even 6.7 I'm not crazy about. I think for sure we're looking at 6.8, 6.9. I'd probably give you the mark for 6.7. But to tell you the truth, I think the answer is more likely to be 7.0. It might actually round up to 7. But let's go with 6.8, 6.9 and see what happens. So again, either one's fine, but let's see what the real answer is. So we're going to change this to 47 this time and execute, and we get 6.85. That 5 makes the 8 round up, so it's 6.9. Okay, either one of those answers is fine. Alright, next one, square root of 72. Where does 72 fall here? 72 falls between the 64 and the 81. So let's find out what the square root of 64 is and the square root of 81 is. Square root of 64, square root of 81. What multiplies by itself to get 64? 8. What multiplies by itself to get 81? 9. Where does 72 fall? Oh boy, that's pretty close to the middle, isn't it? I don't know, I'm going to put it in the middle and then we'll figure it out after that. So, what's the difference from 64 to 82? To go from 64 to 82, you have to add 8. And to go from 72 to 81, you have to add 9. So 72 is just a little bit closer to 64. So what does that mean? It means it's going to be a little less than 8.5. So even 8.3 seems a little bit low to me. I think I would say either 8.4 or even 8.5. It might round up to 8.5. I think both of those are good answers. Okay, I'd probably give you 8.3 as well, but those would be the only answers I'd accept. I should probably stop doing this where I look on this page because you're not going to have this option. You're not going to look on your calculator. But I'm just always interested to see how I did. So let's take a look. You get 8.48, and sure enough, that's going to round up to 8.5. See how we're always able to estimate this to one decimal place. Okay, next one, 146.875. Oh my gosh, that's so confusing. Guess what? When you're estimating, you cannot estimate, to 3 decimal places like this. Just ignore the 0.875. It really doesn't make much difference at all. So just look at the 146. Where does that fall between? 144 and 169. So we need to figure out the square root of 144 and the square root of 169 to start this. Okay, square root of 144. What multiplies by itself to get 144? It's 12. If you didn't know that, you could count over from the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the 12th one, so it must be 12. What multiplies by itself to give 169? Well, it must be 1 more than 12, so it's 13. So what does our answer have to start with? Well, it must start with 12 point something. Notice I don't even need to worry about this decimal here at all. Alright, is 146 closer to 144 or 169? Way closer to 144. So we're looking for the square root of 146. So our decimal has to be definitely way lower than 12.5. I think 12.1 is a pretty good guess. Even 12.0 might not be bad. It might not even round up. But I'm going to go 12.1, maybe 12.2. I really don't think it's going to be 12.2. 146.875. Execute. And we get 12.11, so that doesn't round up, so it's just 12.1. And we said that one too. So make sure you understand that, and I will have this list of perfect squares on the wall in the classroom for you to gaze at. Bye everyone.